This lecture is about logistic regression and classification. Logistic regression is a linear regression model where the dependent variable is categorical. We calculate the probability of a binary response based on one or more predictors. Probability of y is equal to 1 by 1 plus e to the power minus beta 0 plus beta 1 x1 plus beta 2 x2 plus dot 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 2 plus beta k xk, where y is a dependent variable and x1, x2, x3 to xk are the independent variables. Here we see that if the b1 x1 plus b2 x2 plus b3 x3 is 0, then probability is 0.5. When it is infinity, it is 0. When it is minus infinity, is 1. Minus 2, it is 0.12. Plus 2, it is 0.88. Where are the applications? In the category of medicine, predict whether a patient has a given disease or not based on the observed characteristics of the patient, such as age, sex, body mass index, the results of various blood tests. Politics, predict whether an American voter will vote Democratic or Republic based on age, income, sex, race, state of resident votes in previous elections. Engineering, predicting the probability of failure of a given process, system, or product. Sales, prediction of a customer's propensity to purchase a product or halt a subscription. Finance, the predict the likelihood of a homeowner defaulting on a mortgage. So these are the different applications. The output of a logistic regression model is a probability. Often we want to make a binary prediction. We can do this using a threshold. If the probability y is equal to 1 is greater than t or equal to t, predict true. If it is less than t, predict false. Sensitivity and specificity. This is a very interesting discussion on some of the metrics. Say 10% were selected for diabetes testing, 5% tested positive, 4% were actually positive, 1% was incorrectly tested as positive. 5% tested negative, 3% were actually negative, 2% was incorrectly tested as negative. Here the true positive is 4, the true negative is 3, the false positive is 1, and the false negative is 2. We can do this in the form of a confusion matrix. Here we have the person does not have diabetes and the result is negative, then it's a true negative. But the person does not have diabetes but the result is positive, it is known as a false positive. Person does have diabetes and the result is negative, it is called a false negative. And is it does have diabetes and the result is positive, it is true positive. Sensitivity is the true positive by the true positive plus the false negative. It is the true positive rate. The specificity is the true negative by true negative plus the false positive. That is the true negative rate. Here we get the sensitivity is 4 by 4 plus 2. Since the false negative is 2, it is 0.67. The specificity, the true negative is 3 and the false positive is 1. Therefore, we get 0.75. What is precision? Precision or the positive predicted value is a true positive by the true positive plus false positive. The recall or the sensitivity is a true positive by true positive plus false negative. In a pregnancy test, we do not want to report false pregnancies. Therefore, we do not want false positive. Therefore, we want a p to be close to 0. Here, the precision is very important because precision is 2 positive by 2 positive plus false positive. We want a very high precision score. But in case of cancer detection, we do not want to miss a cancer detection. Therefore, we do not want to have false negatives. Therefore, we want the Fn or the false negative to be close to 0. The recall here is very important. Therefore, 2 positive by 2 positive plus false negative. We want a very high recall score. The F score or the F beta score combines precision and recall. The F1 score is a special case of the F beta score where beta is 1 and therefore it is 2 star precision star recall divided by, I think I missed it, divided by precision plus recall. The F beta, which is a much more generalized form and it does not give equal importance to precision and recall, is 1 plus beta square into precision into recall by beta square into precision plus recall. The ROC curve is a graph showing the performance of a classification model at all classification thresholds. The curve plots two parameters, the true positive rate and the false positive rate. The true positive rate is a synonym for recall and is therefore defined as follows: true positive by true positive plus false negative. The false positive rate is defined as follows: false positive by false positive plus true negative. ROC is a plot of the sensitivity and 1 minus specificity. The area under the curve AUC is a good measure of the performance of the logistic classifier. AUC equal to 1 signifies a perfect classifier. AUC equal to 0.5 signifies randomly ordered and no value addition from the classifier. This completes our discussion about logistic regression and classification metrics. Hope you liked it. Bye.